Alright, in this video we're going to be given two triangles. You will be able to use the side-side-side or side-angle-side theorem to decide whether or not the triangles are congruent. Or the second objective is, given a set of points, you will be able to use the distance formula to determine whether two triangles are congruent by side-side-side. So let's start with what the rules mean. So this rule stands for SSS, stands for side. Pencil here. Stands for side. Pencils don't want to work today. Side. 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 So what that means is if oh my gosh, my pencils are not working. So what that means is if three sides of one triangle are congruent to three sides of a second triangle, that means the two triangles are congruent. So let's talk about what an example means. An example would look like. So an example would look like this. If I have two triangles, and if I put markings on them to show you that, if you notice in my picture here, I have one side marked here, two hash marks here, and three hash marks here. That means because these three sides are congruent to these three sides, that means these two triangles would be congruent by side-side-side. Another example that you'll see show up would be something like this. Again, I have two triangles right here. They're connected. They're only marked with two sides here, but what I do know is since they share a side, I can automatically put a marking here, which means these three sides of this triangle are congruent to these three sides of this triangle. Side-side-side works. In my next theorem, it's side, angle, side. And what that means is I need two sides with an angle in between. So if two sides, they call it an included angle. We're going to say if two sides in an included angle are congruent to two sides and an included angle of another triangle, of a second triangle, the two are congruent by side, angle, side. So again, if two sides in an included angle, that means the one in between, are congruent to two sides and an included angle of a second triangle, the two angles, or the two are congruent by side, angle, side. So let's take a look at what this might look like. So again, I might have two triangles here, and I may have two sides marked, but the key feature here is that it has the included angle marked. So the included angle is the angle that comes between the two sides. So here it's the angle between here, and here it's the angle between here. So side, angle, side, side, angle, side. Another one that you'll commonly see is something like this, like an hourglass. And they'll mark these sides and these sides. And what I know is there's only two sides marked. However, I have my vertical angles here that are always congruent. And again, I can say side, angle, side, side, angle, side. So those are side, angle, sides right there. Alright, in my next example, they want us to use the distance formula to determine whether triangle ABC and DEF are congruent. So what they do is give us a whole bunch of points here, and we're supposed to use the distance formula to see if they're congruent. So first let's find the distance between A and B. And if you remember our distance formula, it has the big giant square root, and we plug in, we subtract our x's and subtract our y's here. So A and B would be 5, 5, and 10, 8. So again, my x's are 5 and 10. My y's are 5 and 8. So if I plug in what's underneath the square root, that would be 25 plus 9 gets me 34. So we're going to stop at the square root of 34 there. Let's look at the distance between DE. So again, my points DE are 2, -5, and -3, -8. Again, I do my square root. I subtract my x's. I subtract my y's. And I square them. So my x's again are 2 and -3. And my y's are -5 and -8. So if I type this in right here, 2 minus -3 is 5 squared, that's 25, plus -5 minus -8 is -5 plus 8 squared, which is 9. 3 squared is 9. And here I have square root of 34 equals square root of 34. So far, that works. Now let's test BC, which is 10, 8, and 12, 3. And we're going to test EF over here, which is -3, -8, and -5, -3. So let's do that and test out, see what we get. Again, I subtract my x's and subtract my y's and square them. So my x's here are 10 and 12. And my y's are 8 and 3. So 10 minus 12 is -2 squared, which would be 4. 8 minus 3 is 5 squared, 5, which is squared is 25. That gives me the square root of 29. Or you can just type in everything under the square root and you get 29. Let's do EF here and see if it's the same. Subtract your x's and square it. Subtract your y's and square it. So here I have -3 minus -5 squared, and then I have -8 minus -3 squared. So again, -3 minus -5 is 2 squared, which is 4, plus -8 minus -3, that's -5, and I square that, that's 25. Look at that, that's the square root of 29. So far, this side is congruent to this side is congruent to this side. Now, if these last pair is congruent to each other, using the distance formula, I can say that the two triangles are congruent by side, 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 because I've proved that this side, these sides are congruent, these sides, and let's test to see about these sides. So AC, that A is 5, 5, and C is 12, 3. Over here, DF, D is 2, -5, and F is -5, -3. So again, I'm going to type it in my square root. Subtract your x's, square them. Subtract your y's, square them. I'm going to move my minus sign there so I have a little more space. So my x's, that's 5 and 12. And my y's are 5 and 3. So 5 minus 12 is -7. -7 squared is 49. 5 minus 3 is 2. 2 squared is 4. So 49 plus 4. And 49 plus 4 is 53. Let's check out and see if the next one is the square root of 53. So I subtract my x's and I square it, and then I add the difference of my y's. So my x's are 2 minus -5 squared, -5 minus -3 squared. 2 minus -5 is 7. 7 squared is 49, plus -5 minus -3 is actually -2 squared, which is 4. 49 plus 4, that's a square root of 53. So if you check it out, these two sides were both square root of 34, these two sides were both square root of 29, and these two sides were both square root of 53. So to answer the question, are the two triangles congruent? You would say yes. And what rule? Because all three sides are congruent to each other. Flipping it over to the back, they're asking us if our two triangles are congruent. Well, the two we've learned so far are side, 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 and side, angle, side. This one tells me that the three sides over here are congruent to the three sides over here, so we have side, side, side. The next one, I'm not given sides, I'm given three angles here and three angles here. We have no rule that says that the three angles are congruent to three angles, so this is no. Here I'm given two angles that touch. I'm given a side and an angle on this triangle, and a side and an angle on this triangle. We do know that they touch, so I can put a line there. So I have side, angle, side. Remember, my angle comes between. Side, angle, side, side, angle, side. All set. Now we look carefully at the next one. I have side, angle, side here, but I don't have side, angle, side here. The angle does not come, it's this one right here. The angle does not come between the sides. Over here I'm given a side and an angle and a side and an angle. However, the two triangles touch, so I can make that marking right there and say side, angle, side, side, angle, side. And right here, I'm given two sides here and two sides here. However, the two triangles touch. So I can make a marking here, and I can say side, 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 because all three sides of both are given. The next directions want you to ask what additional information or marks would you have to put on the picture in order for the given proof. So they're asking us for side, angle, side. They've given us the side here. We know that these are vertical angles. If I want to do side, angle, side, I have to do side, angle. This side has to be marked right here in order to be side, angle, side, because it goes side, angle, side. And the next drawing, if I want side, angle, side, I'm given two sides, I need the angle in between. So I need this angle between here and this angle in between here to make side, angle, side. In the next example, they give us a side here. We do know that since the two triangles touch, that one is a given. And what additional information I need for side, side, side would be this side is congruent to this side. Looking at the next example, they also want side, side, side. They're giving us two sides on this one and two sides on this one. I need three sides on each. So I need to mark this side and say it's congruent to this side, making the same amount of markings on both side triangles to make sure we know that they're congruent. If I want side, angle, side here, again I have two touching triangles. They're given marks here, they touch here, and if I want side, angle, side, I need the angle in between. So side, angle, side, and on this triangle on the bottom, side, angle, side, I need this angle right here. And on my last example, I want another side, angle, side. Again, they give us the two side markings here. I have a top triangle and a bottom triangle. I do know that since these are vertical angles, that's a given. They're congruent. And I want side, angle, side, so I need two sides with the angle being in between them. So I have a side here, an angle, and I want my angle to come between the two sides, so I'll put my marking right here, side, angle, marking here.